Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the solar cell or what we call as a photovoltaic device. So this is a symbol of solar cell and it is represented by a cell which is inside a circle, and these arrow are representing the light photons which are falling on this solar cell. So, solar cell is a diode, and it is obviously used in no biasing, which means that neither it is used in forward biasing nor it is used in reverse biasing. I'll tell you why. Because obviously it is a cell which will provide its own voltage in the circuit. So it do not need any external voltage source to be connected across it. Now, solar cell converts the light which is incident on it into the electrical energy. And obviously, you know that solar cell, most of the people today are using solar cell in their homes. So let us discuss how solar cell operates. So we know that obviously in this case you can see that this is a depletion region, and this is a solar cell which is connected to a load resistance. Now load resistance is a high resistance which converts a small value of current into high voltage. So the light of sufficiently high energy, which means that the energy of the photons of light which are falling on the solar cell should be greater than the forbidden energy gap of the base material of the solar cell. So the light of that sufficient energy is falling on the solar cell, and it is falling on the depletion region of the solar cell. And in this depletion region, electron hole pairs are created, and those electron hole pairs are separated away due to the barrier electric field. And as you can see that holes will be accumulated in this side and electrons will be accumulated in this side, so a potential difference will be developed. A high potential difference will be developed, due to which it will act as a battery, and a current will flow like that. So a voltage will be created across the load resistance, and the output voltage will be equal to VA minus VB. Okay, so this is how we can create the current and the voltage across the load resistance by using solar cell. Now, the graph which is plotted between the electric current flowing through the solar cell and intensity of sunlight is a linear graph. Obviously, this is a linear graph which is starting from y-axis, due to the fact that in the absence of sunlight, there is some current which is flowing in the diode, because already there is some polarity across this diode, which when we will connect to the load resistance will result as a current flow. So there is a current in the absence of sunlight also, but as we will increase the intensity of the sunlight, then the electric current will also increase, due to the fact that more electron and hole pairs will be formed, and the polarity or the EMF of the solar cell will increase. So this is a linear graph. And if we draw a VI characteristics graph, so this V is the voltage across the solar cell. This is not the applied voltage, and this is not the biasing voltage. So this is the voltage across the solar cell. So this is V, and this is I current flowing through the load resistance. So this graph is like this, and this is plotted in fourth quadrant, in which voltage is positive and current is negative, because current is reverse current and voltage is positive, because this is the voltage formed in the diode. And obviously we can say that the polarity of the diode in this case is such that P side is positive and N side is negative. This is P side and this is N side. So in this case, this polarity is always taken as positive. So this will be the graph, and this represents the open circuit voltage, which means that if we will connect this diode to an open circuit, no load resistance is connected, then we know that the voltage across the cell when no current is exchanged with it is called as the open circuit voltage, or EMF. We can also call it as EMF, and this is the short circuit current. Now, when we will short circuit the terminals of this cell without any load resistance, we can connect directly these two terminals. Then the current flowing through this diode will be called as short circuit current. Okay, so this will be the VI characteristic graph of the solar cell. So this was all the kinds of diode, and in the next video we will be discussing the numerical problems on the diode, and after that video the last video would be about logic gates. Thank you.